All right, so in this video, we're going to talk about Pythagorean triples. Okay, we just went over the Pythagorean theorem, so we're going to use the Pythagorean theorem here to find the missing side length. Okay, and we need to understand what Pythagorean triples are. Okay, if all three side lengths are whole numbers, then we're going to consider those Pythagorean triples. Okay, if you can remember Pythagorean triples, it makes a lot of the math you're going to be working with a lot easier, because those do occur not often, but often enough. And if you remember those, then you can save some time. You can be more efficient down the line when we're dealing with right triangles that happen to be Pythagorean triples. Okay, so let's look at number one here. You've got the two legs here are 3 and 4, and we need to find the hypotenuse. Okay, the side opposite the right angle is the hypotenuse. So we're going to plug those values into the Pythagorean theorem, okay, and we're going to solve for C, okay? So 3 squared is 9, 4 squared is 16. Add those together and get 25, okay? Take the square root of both sides, so the hypotenuse here is going to be 5, okay? So let's add that to the table, and that's a Pythagorean triple because all three side lengths are whole numbers, okay? So 3, 4, 5. Now, if you were to double the size of that triangle, okay, in terms of doubling all the side lengths, that's going to be a Pythagorean triple as well. So if you double the 3, you get 6. If you double the 4, you get 8. If you double the 5, you get 10, okay? So the 3, 4, 5 is the most basic of those Pythagorean triples, but 6, 8, 10 would also be a Pythagorean triple. That's twice the side lengths of this most basic one, 3, 4, 5, okay? You could multiply all the sides by 10. So 30, 40, 50 would be a Pythagorean triple as well, okay? And you can verify that using a calculator real quick. If you square 30 and 40 and add those together, you're going to get the same value as if you squared 50, okay? Which would be 2,500, all right? Okay, try to do 2, 3, and 4, and pause the video here, and then come back and check your work. All right, so let's take a look at number 2. Okay, in this case, we're going to be solving for this missing leg over here. So the hypotenuse is 13, and the smaller leg is 5. Okay, I'm going to call 5 A in this case. Okay, so we're going to be solving for B. All right, so when I square 5, I get 25. When I square 13, I get 169. Okay, I'm going to subtract 25 from both sides, which gives me B squared value of 144. Take the square root of both sides, and we get 12. Okay. So this is another really common Pythagorean triple. We call it the 5, 12, 13 triple, okay? Again, if you double those sides, 10, 24, and 26, that's also going to work out. If you triple those sides, 15, 36, and 39, that's also going to be a Pythagorean triple, and so on and so on. That pattern will continue, okay? Let's look at number 3. Okay, in problem 3, we're going to be solving for the smaller of the two legs, okay? The longer leg is 15, the hypotenuse is 17, so I'm going to call the leg we're solving for A, okay? So 15 squared is going to be 225, 17 squared is going to be 289, okay? So when you subtract those, you get 64, okay? And then I take the square root of both sides, and my shorter leg has a value of 8, okay? So 8, 15, 17 is another fairly common, not as common as the 3, 4, 5 or the 5, 12, 13 really, in the problems you'll see moving forward. But still one you'll see fairly often, okay? Again, same pattern works if you double, triple, multiply times 1,000, multiply times 24. As long as you do it to all three sides, that will continue to be a Pythagorean triple, okay? One more to finish it up. And finally, number 4 here, we're solving for the hypotenuse again. Just wanted to show you another Pythagorean triple here. So we're solving for C. So 9 squared plus 40 squared equals C squared. Well, 9 squared is 81. Okay, 40 squared is 1,600. When I add those together, I get 1,681. And then I take the square root of both sides, and I get 41. So another Pythagorean triple that you'll see on occasion is 9, 40, and 41, okay? There are other Pythagorean triples that we didn't go over here that you might see pretty often. So just once you see a Pythagorean triple, try to commit it to memory, and it's going to make your life a little easier down the road when we're dealing with trigonometry.